Welcome to the presentation of PQA-Net, DEEP, a no-reference point cloud quality assessment while multi-viewed projection. My name is Liu Qi, and my supervisor is Yuan Hui. I'm very glad to introduce our work to you. Okay, let's start our presentation. As we know, 3D point cloud is becoming popular due to its capability to represent the real world for advanced content modality in modern communication systems. In view of its wide applications, especially for immersive communication towards human perception, quality metrics for point clouds are essential. The existing quality assessment methods can be roughly divided into three categories. For reference point cloud quality assessment, FRPCQA, reduced reference point cloud quality assessment, RRPCQA, and no reference point cloud quality assessment, NRPCQA. FRPCQA requires full access to the original point cloud, and RRPCQA relies on a part of the original point cloud. Recently, major progresses in FRPCQA and RRPCQA have been made. However, there is no NR quality assessment for point clouds by now. Currently, existing point cloud quality evaluations relies on a full or part of the original point cloud, which severely limits their applications. How to overcome this problem? To overcome this problem, we propose a novel deep learning-based no-reference point cloud quality assessment method, namely PQA-Net. Specifically, the PQA-Net consists of a multi-view-based drawing feature extraction and fusion module, namely MVFEF, a distortion type identification module, namely DTI, and a quality vector prediction module, namely QVP. The DTI and the QVP modules share the feature generated from the MVFEF module. By using the distortion type labels, the DTI and the MVFEF modules are first pre-trained to initiate the network parameters, based on which the whole network is then jointly trained to finally evaluate the point cloud quality. This is the overview of the proposed PQA-Net, and the code of the proposed model had made publicly available in GitHub. You can find it by the link in the PPT. And this is the detailed architecture of the proposed PQA-Net. The MVFEF is to transform the 6 projections to a 384-dimension quality realized feature vector. It includes 4 line-to-line CNN blocks. The DTI and the QVP are conducted by a generalized device normalization (JDN), fully connection FC, dropout DO, and softmax operations. Let's see how to implement PQA-Net. For a point cloud, one can only see its 2D appearance from a certain viewpoint at the same time. Thus, we first projected a point cloud onto 6 2D images along the 3 orthogonal projections and then perform center cropping to obtain 6 cropped images. Since the cross entropy loss is very suitable for classification, to classify the distortion type effectively and quickly, the cross-entropy loss L1 over the mini batch is used. Once the predicted score is obtained, the PRCC loss function between the predicted scores and the ground truth in the mini batch is computed as L2. By taking the accuracy of distortion type classification task into account, we defined the hybrid loss function of PQA-Net as L. To augment the dataset, each point cloud was treated as 12 versions by routing it to 12 different viewpoints, as shown in above figure. PQA-Net adopts a two-step sprint to train the multiple multitask neural network. At the first step, the model parameters W of the MVFEF module and the model parameters W1 of the DTI module are trained by minimizing the loss function L1. In the second step, all the model parameters are trained by minimizing the loss function L. As a byproduct, PQA-Net also outputs the distortion type of a point cloud. The confusion matrix, which is used to summarize the performance of a classification algorithm, is shown in above table. From the table, we can see that for specific distortion type noise, the accuracy predicted by PQA-Net is as high as 1. The accuracy comparison results with the existing FR and RR point cloud matrix is shown in above table. We can see that the VRFPP has the best performance, whose PLCC and SRCC are both as high as 0.82, and PQA-Net is the second best, whose PLCC and SRCC are as high as 0.7 and 0.69 respectively. Limited by on-file usage of the original information, the performance of NR method is reasonably worse than the FR or RR methods. From the results, however, we can see that the performance of the proposed PQA-Net is only slightly lower than the best FR method VRFPP, indicating the advantage of the proposed PQA-Net. To fully test the performance of PQA-Net, we also conduct further experiments on the other subjective datasets. The subjective datasets are briefly introduced in above table. Detailed experiment results are given in below table, from which we can see that the performance on the RRPC dataset is the worst. This is because the amount of training data of the RRPC dataset is very small, which greatly limits the performance of the proposed PQA-Net. The performance of the PQA-Net is the best on STTU PCQA dataset, because the difference between the distortion types on STTU PCQA dataset is widely. My presentation is finished, and thanks for your attention. Welcome everyone to contact us to discuss learning point cloud knowledge. Our email is below. Bye.